Otkin, Abby Kale, Jackie Van Ort, Bailey Pitzenberger, Casey Otkin, Mackenzie Van Gerpen. You have something at the office.
You don't know how to text me Facebook posts? Because they're always stupid things like, I don't even know. What? Yeah, I know.
This is my sweatshirt last period.
Back road. Games thing. Right. Let's see, they marked absence. Alright, I'll be with you guys here in a second. I gotta send one email. Okay, so let's talk about what we're going into today. I want to do a quick example of supplementary, complementary today, just kind of give you kind of the algebra style problem, what you can kind of expect. You'll have a few of these, don't get me wrong, you're going to have a few where you have to do some algebra. Most of the problems that we're going to give you, most of them when I looked at the number I gave you, was like look at a picture, name an obtuse angle, name two that are adjacent to each other, or give me two vertical angles that are acute. So they have you naming angles today. So you have to look at the relationships there. But there's going to be a few you have to do some algebra. So I'm going to cover those today because those are the things that I think most people will probably have questions on. So that's the like the three types of examples I'm going to work through. We will have homework. I'm going to make it due Thursday this week. It's pretty straightforward. I believe it's less than what you just had. So we should be fine. Just a reminder, this week, maybe Thursday, I'm going to hand out your practice guide for next week. Next Thursday is your test in here, okay, for chapter 1. So this will give you kind of a week's heads up. We always review the Tuesday, Wednesday leading up to it. So we take a 2-day, we go over the practice test that I handed out, and then I collect that practice test on test day. That's kind of how it works. Okay, any questions with kind of the schedule this week? All right, so let's start reading on it. Let's talk about the supplementary type of problems that we could have. It could be just a simple problem like this, where they state that these lines are crossing each other. It could be something like AB here is intersecting CB. So maybe that's based on the instructions, that, you know, AB intersects BC. Now, what does that mean when they write it like that? What they're hinting at is that you have straight lines. That's what they're hinting at. Sometimes they always say opposite rays, but this is just saying that they're straight. That's a line, that's a line. They have to be straight, there can't be any curves to a line. So why that's important is sometimes they're gonna give you just some basic information. They could do something like this. Let's see, I better make that an 18. There you go. Just make sure it works out. Alright, now the reason why this is important, why you need something like this, the idea here is pretty straightforward, that you can't just add supplementary angles together, right? That's kind of what I said, we're gonna start with supplementary, but vertical goes with it, right? Because most people look at this and they go, okay, well, these two angles add to make 180. Yeah, it's true, but you wouldn't need to do those two because they have two different variables. So I wouldn't want to use those two. So you could use vertical angles on this problem, or just go the other direction. Just go this way. Just go this direction. Those have to be 180, going up and down. There's two different ways you could do that. You could solve for y first, or you could solve for x first because of the way the vertical angles work. So I'm gonna do the idea of going up and down. 3y plus 18 is equal to 50. Hopefully this works out. I might have to modify the problem here. Okay. So, jeez, what am I doing? Amateur mistake here. Okay. So you add the two angles together, they make a straight line, so they make 180 degrees. Does that make sense to everyone? Because that's supplementary, right? They're a linear pair, they're a straight line with each other. So that's what I would do first. I'm going to solve this, I'm going to add these two together, so that's what, a 68 equals 180 here. That's a 3y. And then I'm going to subtract that 68 across. So this is one attempt at how to solve this. I can show you the other way to do this here in a second. But I would subtract the 68 over this side. So it's 3y equals 180 minus 68. Okay, then next step, we actually subtract that out. So 3y equals, let's see, what is that? 20, what is that? 112, is that right? Okay. And then the last step is divide by 3. Let's see, do I need to modify anything here? Because I want to make sure this works. I'll just make the decimal. It won't work out as a perfect number, but divided by 3, divided by 3, these would cancel, and you get whatever decimal this would be. Because I think you'll have a couple that will be decimals today. So 112 divided by 3, what is that? It's roughly 3, it's a 9, carry 2 down. It's roughly about 37-ish, 37 point something. So, all right. Any questions with how you need to start that problem? Okay, now, why you'd ever need that? I know what this angle would be, right? If you were to take that number, whatever that number is, 37 point something, plug it in here, what you should get, common sense, what this number is going to be, this number here, it's going to be 130. Like when you plug that number back in. Now why that's important is because now you can solve this direction. These two have to add to be 180. Because now that you have that number plugged in, or the other idea that I said earlier, you can do vertical angles. That could work too. Okay, which one do you want to do? You want to do vertical, or do you want to do the supplementary thing, the linear pair? What's your call? Vertical? Okay, we'll do the vertical angles now. So the vertical angles are the 50 and that 4x plus 12. Vertical angles are equal to each other. So those two, so 4x plus 12 should equal the 50. So then you're going to subtract the 12 across. And that should be what, 38? I subtract that over. And then the last step, divide by 4. So the 4's would cancel, and this would be your answer. 38 divided by 4, it's roughly just over the number 9. Just over 9, 9 something, not quite 10. 40 divided by 4 is 10, so it's between 9 and 10. Maybe 9 and a half, maybe. 9 and a quarter. Alright, any questions on how to find x and y? Yeah, I know they didn't work out nice and pretty, but you can get decimals. So if you want to leave it a fraction, that's fine, you can do that. Alright, any questions, comments, concerns about that problem, the style of it? What you have to do. Now again, very, very open-ended. I could have started with this first. Found x, and then use that, plug that number back in to find y. Because then these two add up to 380, kind of like what I was showing you earlier, but this concept is 130, that number. Okay, so there's multiple ways to do this problem. You just, if they make a straight line, they add to make 180. If they're vertical, they're equal. Now, the other style of problem that you're gonna have today is if they do something like this. Jeez, that's a terrible straight line. What am I doing? Alright, so let's call this x and y. And let's call this w and z. Alright, and that's point P. Alright. WZ line. Alright, what does this mean? What did we talk about yesterday? What does that little upside down T mean? Perpendicular. Now what does perpendicular hint at? What does it mean? 90 degrees, yeah. So what you have here is you have basically a bunch of right angles. That's what you need to realize. All 4 of them are right. That's what perpendicular means. That's what the little upside down T means. That they're going to intersect at a perfect 90s, right angles. Okay? They're flush to each other, they're right. Okay? Now, whatever these are, it doesn't matter what the variables can be in here, you can always solve these things out. Sometimes they're going to do stuff like this. This is 48, and this is a x plus 2, and this is a y minus 5, and you know, this is a z, this is a 3z, something like that. They could solve, and you just need to figure out what x, y, and z is. So it's common sense, because what are each of those angles? Okay, I should put 48 there. Maybe 48 plus w. Jeez, what am I doing? Why just use the same letters? What am I doing? B, C, and D, sorry. Alright, so they could ask you to solve for letters here. So what you need to do is just realize that in each of those corners, those are all 90s. That's what perpendicular means. So each of those angles you can solve for themselves. Like this part right here, I'll solve for B first. That's 90. So B minus 5 is equal to 90. And then solve. You'd add the 5 across, so B should be 95 or something like that. Or whatever that is. That doesn't make sense, but you get the idea, right? That you solve for each one. You're going to have a couple problems where you're going to have that, where you're going to have to solve for a certain variable, no matter what those things are, plugging them in. Obviously, the numbers I made up don't make any sense, because the numbers are 90s in those corners, but do you see how I'm solving? I'll keep going. I'll keep solving for each one of these, because you're trying to find what each of these numbers are. These numbers can be anything, but you know when you plug the number back in, what angle will be sitting there. 90, right? Because if I plug a 95 in here, what's 95 minus 5? 90 degrees, so it doesn't work, right? But you get whatever numbers you have. Okay, and then A, same thing. A plus 48 is equal to 9, or, yeah. A plus 48 is equal to 90. To solve for A, you just subtract the 48 across. So 90 minus 48. What was that, 42? Solve that out. So that's what they're going to have you do. They're going to have you solve for just random variables. On that style of picture, you know that you have 90s because they said that in the instructions. And then you can solve for C, and C would be 30, and then D would be a 88, something like that. Okay, is there any questions with what they're going to ask you to do today? Solving for variables, knowing how to set up linear pairs versus vertical angles are equal. Okay, now, there is going to be some challenge questions in there for sure. There's a couple where they're going to give you like a verbal sentence, a verbal expression, and they want you to solve it, okay? A verbal expression. In fact, I'm gonna do one right now for you. I'm gonna write one on the board. But this is like, you have about 5 or 6 of these where you have to, solve for letters, variable that's missing, that sort of thing. But the verbal expression is the one that we need to look at. Okay? Alright, let me go to the work here. Let's talk about this next problem. Alright. So, angle ABC and angle CBD be adjacent form a linear pair. Find each angle if angle CBD is 5 more than twice angle ABC. Okay. Okay, so what this is just a verbal expression, right? So it's a word sentence that's trying to give you enough hints that you can solve this thing out. Okay? So the first sentence usually gives you a picture of what this thing is looking like, right? So if we look at this picture, we have ABC, we have CBD, right? Those are adjacent angles to each other. Okay, so that means they're literally side by side, they're touching. Okay, so I could draw that. But the thing is, if we keep continuing in that sentence, they explain something else. What do they form? A linear pair. What does that mean? What does a linear pair mean? Yeah, straight line, right? So when they're side by side, they're forming this. This is what they're forming, a straight line when they're adjacent to each other. So that's the description. So I know that for a fact that I can add these two angles together and it makes 180. Does that make sense now? Now I'm gonna put the letters in here. So here's one of the angles. I don't know if this is true or not, but this is ABC for my picture, because I don't have a picture to go with it. So there's ABC, B is the vertex, right? And then the other angle is CBD, so this would be the other one. So there's my two angles. Okay, does everyone understand it? Now I'm gonna put what they're giving me. Now the second sentence says, find each angle, so I need to find the values of them. If CBD, this angle, is 5 more than twice what this angle is. Okay, so I don't care how you do this. I don't care if you pick this as X and then you put all the variables on this thing, but this angle here is 5 more than twice what the other angle is, and this would be the other angle. Does that make sense now? So CBD is 5 more than twice ABC. So I just put a variable in there. 5 more than means to add more than, and then twice is to multiply by 2, whatever ABC is. So I picked a variable for ABC. So now I can solve this. X plus 5 plus 2x equals 180. I can add the two together, this angle plus the other one, and now I can solve for x and I can plug it back in. So what I have here, 2x plus 1x, that's 3 x's, and I can solve this. I subtract the 5 across, so I get a 175, and divide by 3. And that'll be a decimal, but it's fine. Okay, 175 divided by 3, what is that? It's a 5, bring down the 2, so it's a 5, bring down the 2, 25, so 28, or 38, it's roughly about 38 point something, 38.3. So there you go, so it's about 38 roughly in number, 38 degrees, point something. Okay, well that's 38 degrees, then this is whatever's left over. It's 5, it's twice what that 38 number is, and then you add 5 to it. So, okay, I think it's 38.3, pretty sure. And then the other number would be whatever's left from 180. Okay, but you see what you need to do. You have to find x plug it back into each of these, and then you have to find each of those numbers. So this is roughly a 38, just put roughly, 38 degrees. And this is whatever's left, so that'd be 142 degrees. If I were to plug it back in. All right, any questions with the verbal expression versus what you're gonna have to do in the other ones? I think you only have a few of these. Okay, but I just wanna make sure that you understand what you're gonna have to do with it. You're gonna have to draw your own picture, make sure you get the setup. Okay, all right, here's your homework today. It's due on Friday, so it should be pretty straightforward, or due Thursday, I mean, sorry. Due Thursday. All right, it is page 50. Number 1, 2, 4, 5, 8 through 17, 19 through 28. That's it. Okay, I think there's a couple challenge questions right here. There's a couple challenge questions at the end, but the rest of these, most of these anyway, are just look at a picture, name an object. Name like 2 obtuse angles, so they're very open-ended. I mean, there's, on some of those pictures, there could be 30 different answers for like, just name 2 obtuse angles. So, just make sure that you give me something that fits that type of question. Okay, alright, the rest of them is yours. You can move around, move desks around. You have 21 minutes to kind of work together. Okay. There you go. And as you guys are working, I'm going to hand out some old papers, stuff you turned in yesterday. Good stuff. Scores. Trinity. Cassidy.
Okay, so WB,
Cover.
yeah, I think so WBU and then YBZ.
Lucy.
Wait. Was that to approve one then?
Okay, Trish. Remember, I didn't count those 47 through whatever. Because those are the challenge.
Oh, we're doing Jason now, that's why.
Yeah.
So yeah, you're right.
Then, Trin, here's the other one that you trained the other day. Perfect. Alright, hey, page 31, that should be in your possession. Just to give you kind of, because I think I said it yesterday, remember those last couple, I think it was like 47 through 50 and then 53, 54, I don't count those against your scores. Those were the challenge questions, those really tough algebra problems. So if you see that you miss them, but it didn't affect your score at the top, yeah, because it was like 47 through 50, I didn't count those. Okay, the ones at the top did. Okay, if you did not get a page 31 back, it's because you never turned it in, or A, you didn't put your name on it, and you turned it in during another period. So it might have been in the recycling bin in the back. So, or you didn't do it. So if you didn't get a page 31 back, you should know where it's at.
Take that out. Yeah.
Yes, ma'am.
Okay. So 10x
Yeah, it could even went the other direction, there's other ones you could use. Yes, that will work.
But I thought you had to do the -10 for 6. Oh, I thought you said no to that.
Complimentary. The angles are not equal.
Yeah, I'm pretty sure. So 90.
But it's complimentary, not equal.
90.
Oh, yeah, okay.
Congruent means you could set them equal to each other.
Someone on there.
Oh, Good job, Ross.
Yeah.
What is what? They're like, they're not. Like, this. Oh, so you draw it that way. Like, it'd be like that. So like this way, they're all this. It's just a bunch of. So like.
These over. Alright. Page 16. Oh, no.
Oh, support of 90, they equal 90, 2b plus 1 equals 90.
Oh, no.
Oh, we already.
That would be what we were talking in
So it's 90, yeah. So is that it? Find the values of A, B, is that A, X,
Good thing I drew a nice square.
number two.
Hey, we got book number 2. This is weird. They're coming in one at a time.
Yeah, they come from different vendors
Oh, okay.
through Amazon,
Ah,
so.
thanks.
So,
Sorry.
I don't know if we know what
Angles, you got two angles, right? You got 3A minus 27, 2B plus 14. And they are perpendicular, so it's just like that one unit, that green picture. They're adjacent and they're perpendicular. What are these little angles? You could do two vertical.
So,
Because they're both perpendicular. They're adjacent. So each
what'd you say again? D,
That's it.
yup, E, F, G.
is that like the 2A one? Because they said they're adjacent, but they're also.
2 on 2.
Okay.
Vertical. Okay, so. 2, so. Wait, oh, okay, so H, G, E, A, G, D. Is that not 2? So H, G, E, and then C, E, G, D. Oh, would that work? E, G, D.
Yeah.
Okay.
I really just did something. Did you do that too? How'd you get 14? Oh, we did the bottom one first. Why did we do
I know what I'm doing, and everybody's like, really?
Oh, is this one? Okay.
Wow. Because the answer is like,
Like A, D, C, C, D, E.
that. Where are you from? Like, we're not there yet.
2 complements, non-adjacent. So, okay. So C, D, E.
That's a good number.
Non-adjacent?
Of course you're on.
No, I already heard it. What are you talking
Or, wait, no.
What do you got?
Okay, so number 12. 2 complementary non-adjacent.
So two angles that would add, that are not next to each other. That would add and make 90. Complementary has to add to make 90. That's what complementary means. And then they said they have to add. That's what complementary means.
Okay.
Okay. Yep.
No, we just did the complementary ones wrong, so just wait, it was wrong.
You're right.
Yep, already sent it over, and so let's read that. Two complimentary adjacent. I'm just going back to so we see that. Another one.
There you go.
Oh, and then CCA.
It looks like you don't know that's what you wrote.
Oh, do it now.
You're there.
Right up.
That's an S. It looks like
Okay, let's go back to 11.
looks like it's a little fancy and fancy. Wow, that's great grammar. I just bet it. I guess they're close to trying to figure out.
So two complimentary.
It's not really.